today is, thank God it's Friday, May the 7th. This is a very important day because this is the AP Chemistry test was this morning. Several students came back, felt confident about it, so that is good. This will be the last year they'll probably feel confident about it. You know, they move to one period class next year instead of 2 periods. So it means I have half the time, so it'll cover half the material. So AP Chemistry next year is going to be 1 period instead of 2.
Oh, I would have signed up for it.
What?
Yeah, I would have signed up. I only did it because it was what, 10 minutes.
Well, 2 periods is, trust me, it's very beneficial. All right, but what we're making here is some cabbage juice. Okay, I don't know if you can begin to see the solution color is beginning to turn a purple, bluish purple kind of color as the juice is leaching out of the leaves. Just a head of cabbage I bought at Walmart. And yes, I had to use my own money. Okay, so I'm that committed to you. So you better pay attention today. Because I think I'm $2.50 in on that. And so.
Hey, that's like a gallon of gas.
Yeah. All right, so what I have here, while this is finishing cooking, I have some phenolphthalein. I have some 0.1 molar HCl in the test tube. Phenolphthalein is probably one of the most common acid-base indicators. You just put 1 or 2 drops, it's all it's going to take. Okay? As it dissolves, it's colorless in the acid. But as I begin to add base, now this is 0.1 molar acid. This is 1 molar base. So what does that mean about how much of this it should take to neutralize this? About 1/10 as much, right? So let's move that down. So as I add this in, you see the magenta color, but with a little swirl, it goes away. Okay, because it's real concentrated at the top, but then as the OH minuses find the H pluses, as the OH minuses find the H pluses, the magenta goes away. Okay, but notice that took a pretty good amount of time. So I can take to where, let's see if 1 drop, nope. Still going away, so that means there's still more acid than there is base. Ooh, now it's really taking a long time to go away, but it did indeed go away. Okay, now that looks to me, that made it to the bottom. Now the pink stain, okay? That tells me, okay, now I have more base than I do acid. Now I only put in 3 drops, so I mean I barely have more base than I do acid, but I have more base. But if I take the acid, I can neutralize back. Now it's going to take more. And we can make the magenta go away. We can make the magenta not go away. Okay, we make the magenta go away. And then going back again, I'm going to make 1 drop. So 1 drop causes it to change back. That's how close we are to the neutral point on this. Now when it's magenta, that means that we have more base. Now, I need some hot hands. This could be tricky. I am on video, so you're going to get to see me drop this on video.
Yeah, I'll just grab it.
These are going to be my hot hands. Okay? So now I'm just going to pour some of this into each of these beakers.
not taste like it.
Yeah, I'm sure it does not taste like Gatorade.
Okay?
No way.
What do you even use cabbage for other than messing up a salad?
Coleslaw.
Coleslaw.
Oh yeah, we had a whole conversation about coleslaw yesterday.
Okay, but like,
Do I have about the same amount in each one?
About.
Pretty close?
Mhm.
Okay, so this is pretty much just the cabbage juice. Now, if I go and add some HCl, let's put a whole bunch of HCl in here,
oh shoot, it's pink.
okay? Use a little stirring rod, okay? So, just like with phenolphthalein, now phenolphthalein is either colorless or it's magenta. Here, now, strong acid is going to red. Now I'm going to take just some vinegar. Does anybody remember what vinegar is? It is an acid. Which acid? Acetic acid. It's a 5% solution of acetic acid. I'm just going to put like 1 drop in. I might need more. Oh, golly. Oh man, I can't believe I should just put 1 drop. Okay, I'm going to put 1 drop of the base in. I want to try and get it. You can see it's a little bit more purpley color. So the pH, there we go. Okay, so now we're a little bit more purple. Then we can get blue. Then if I go and add a little bit more NH4, this is ammonia, which is our most common weak base. Put a little bit in there. Ooh. Ah. Okay. And then if I go with NaOH, the strong base, we get green, and eventually it'll go more towards the yellow. But see, with the red cabbage, I mean, it's really kind of cool that we can get so many different colors of the rainbow just from one juice. So some indicators have multiple colors. Phenolphthalein is just colorless and magenta. But a universal indicator is one, like the pH paper, changes color all the way up the line, different things. Maybe, who knows, maybe that pH paper really is made out of cabbage juice, you know, soaked in cabbage juice. I don't think so, but okay. You can kind of see how as it's going, it's coming more green. More towards the lighter green, more towards the yellow. Okay. I can probably work that and get that to be a little bit more green. Let's see. I like playing with the colors. Okay. That's a little bit, that's kind of a bluish green kind of color. Anyway, just the rainbow right there. I mean, it just, to me, just nature amazes me that with the difference in pH, you can get all these different colors just from red cabbage juice. Okay? I don't know of any other natural indicators like that, but I'm sure there are some. Okay? Now, what will happen? What's going to happen, you think, if I put them all together?
It's gonna turn to dark blue.
It's gonna go back to the blue.
So
Back
the
to
original
normal
color.
cabbage.
We'll
The
see.
cabbage juice color.
Or just a really, really just muddy looking.
Okay, so there's the two extremes. Okay? Getting closer back to that blue, aren't we? Well, it's a greenish blue. Okay, so we end up somewhere on this. So what do you think? Is it acidic or basic?
It's more on the basic side.
It looks like it's more a little bit on the basic side of neutral. Do I have any pH paper? I think this is pH paper. So if I touch this, let's just see. Okay, if you guys remember, so I see a little bit of a green kind of color.
I think it's like
That was pretty close, right at 7, right? Wasn't the yellowish green, you know, right at 7? So I think we're pretty close to being neutral in here. So the cabbage juice. So I wish I hadn't dumped it all out. I was curious to see what the pH was of the actual cabbage juice, because it may have been slightly acidic or basic. Do I?
just make some.
Make some more? Let's see if there's any residual.
Oh.
Just touch the cabbage leaves. Let's do this. Oh, shoot. It was definitely turning colors though. Ah. Oh, there we go.
Where did you just put the paper?
Okay, so it's getting that darker green, which is that higher pH. That was like your 8 or 9 on the pH. Okay, so indicators. What would be a definition of an indicator?
Something that changes.
According to
pH.
acid, base, or pH. Okay? Now, I don't care what y'all say. That's pretty cool. I think it is. That's why I like chemistry. Cool stuff. Get to play. Make different colors. That's as artsy as I get. Okay? So I can't draw at all. All right. So. What?
The concept of colors is just running back through my head.
You know all the notes we took on colors.
All that, yeah, when we were dealing with electrons and all that.
How
Yeah.
colors work.
Yeah.
Fire.
Color is a color.
No, the other one.
You know why there's colors that don't-
My green's not the same as your.
That's right. What we
wait, no.
see,
We're
what
not
we
talking
see
about-
aren't necessarily always the same color.
Because like, we all see this as white. Well, what is white really?
What if?
The absence of color.
Yeah, like, what is really white?
Okay, so there's just the same kind of thing that we did right here. So that the kind of bluish purple, that was really neutralish, okay? Then we went to red, and we actually went to a green. When you get up to 13, 14, it's much more towards the yellow. Okay, so and that just kind of shows that. And then we talked that there are other indicators that change colors at different pHs. All right, so Bronsted-Lowry, what's the definition of Bronsted-Lowry?
Proton.
An acid is a molecule or ion is a proton donor,
Proton, and what is a proton?
a hydrogen
An
atom.
H plus, not a hydrogen atom, a hydrogen ion. H plus ion is a proton. So we looked through and we did all that, okay? We went through and figured out conjugate acids and bases and figured those things out. And we went through this comprehension check and we finished up with Lewis definition. Okay, now I skipped over that part. So then we started talking about pH. Okay? And if we have an acid, you have more H plus. If you have a base, you have more OH minus. But if it's neutral, H plus and OH minus equal one another. Okay? What's the pH going to be over here? I know, but what's the pH going to be? You know, above 7. What's pH going to be over here? Below 7. Okay? So we finished the day, we had 4 important equations. pH is equal to
Negative log of H3O plus
and what do the brackets mean again? The
molarity.
concentration of the H3O plus in terms of molarity. So POH is equal to negative log OH minus. So when you take the P of something, you're taking the negative log of it. Then we found that Kw, the equilibrium constant for water, is 1 times 10 to the minus 14th, which means that H3O plus times the OH minus concentration in any water solution always equals this number. So if I add in more acid, what happens to my OH? It goes down. So as H3O plus goes up, OH minus goes down. As OH minus goes up, H3O plus goes down, but their product of their concentrations always equals this number. Why is that? I don't have a clue. It just is. Okay?
That's how I feel about this whole
It
class.
just is.
I don't know. Mr. Hobbs
It
said
just
it. It is what it is.
That's why a kid in AP Chemistry came up with his slogan is, one day you'll make sense of this nonsense. And then I added in which we call chemistry. And so, but we're making sense of the nonsense. Now, when we take the negative log of both sides of this, I showed you the proof yesterday, pH plus POH equals 14. From these four equations, we can figure anything we need to figure. Okay? So let's figure.
Yay.
That's all just an explanation of everything I just gave you. Okay? So, given the following OH minus values, determine H3O plus. So which equation do you think we're going to want to use to solve this one? Let's just, one, two, three, or four. Four? Well, I probably want to use three. Now, you can use four. Now, you can use four. Because I could go through, and this is my OH minus, so I could use them all. I could find my POH because I know the OH minus. I could then subtract it from 14 to find the pH. And once I have the pH, I can plug it into here and raise this. Now, just so you know, in this case, H3O plus, what did we say logarithms were?
10 times something.
10 raised to some power, right? So if you bring the negative sign over here and you want to get rid of log, you got to raise 10 to this power. So H3O plus is always going to be 10 to the negative pH. That's just rearranging this same equation for H3O plus. That's how you do the algebra. So what's OH minus going to be? 10 to the negative P OH. Okay, so it's not really a new equation, it's just solving for the other part. But the simplest way to do this problem is to do what?
Just do all of them.
Okay, Madison, what?
5, 10 times, or 1 times 10 to the negative 14 by OH minus.
And you get H3O plus. Okay? So, let's go ahead and do that. So we say H3O plus is going to equal 1 times 10 to the minus 14th divided by 2.67 times 10 to the minus 6th. Now you might need to refresh yourself how to put things into your calculator and do scientific notation on your calculator. What do we get? Well, you probably want to put it in scientific notation.
4 times 10 to the negative
Well,
9.
this is, we have 3 sig figs here. We can assume this is 1.00. So 3 sig figs, it's going to be
4.00
4.00.
times 10 to the negative 9.
Now, did it just come out to 0.000004 on the calculator? Okay, that means you're right on the edge of what your calculator can show on display. It's rounding the last part. So put it into scientific notation. Everybody should know how to change the mode to scientific notation.
Mode, science.
It's not going to be 4.00.
3.745 times
3.75,
Oh,
That's under the first.
okay, times 10 to the minus 9. So in your calculator, when you're right on the edge of how many places it can show, it rounds up to that last digit. So when it's like that, 0.000000 something, you probably need to change it into scientific notation to get all the digits. Okay? So we would do the exact same thing on this one, right? So what do we do on this? If we have H3O plus, we want OH minus.
Just do the same thing.
Do the same thing.
The other way.
It's gonna be 1 times 10 to the minus 14 divided by this. It's gonna give you OH minus. Okay? So if we know H plus, we automatically know OH minus. If we know OH minus, we automatically know H plus. Now, let's just say I want the pH of this solution. How do I find pH then? Which we just did.
Then you do the negative 1 times it.
Okay, then take the negative log of this. So you have this and take the negative log.
How? Many rounds?
So the pH, okay, so for sig figs, when you're taking the log, however many decimal places there are, that's how many, when you take the log, that's how many sig figs you have. So this would be to 2.
8.43.
No, not 2 decimals, 2 to 6, so 8.4. Now, I am not going to follow sig fig and make you, know how to do sig figs on law roads, but there is a rule. Okay? So pH, now is there another way we could have done this? Just given this information right here.
Find the POH, the negative log of the POH which you're given, and then plug that into the pH plus POH equals 4.
That's right, we could just take the negative log of this number, okay? Then, that's gonna give me the POH, then just subtract from 14. Okay, so there's gonna be multiple ways, because these all are related to one another, so you can always get from point A to point B.
What is the POH? Is that just another measure?
Okay, POH is just, again, in any water solution, you always have some H plus and some OH minus. The pH scale is just the favorite scale, but the POH scale is identical just in terms of the base part versus the acid part. But for some reason, we don't care about POH, we just care about pH. But they're two identical, H3O plus, OH minus, always in water. So again, as one goes up, the other goes down, so they're totally related to one another. We just have picked pH as the favored unit. All right, so we good to be able to do all of these? Because I could do the exact same thing here. I could find the pH of this one, all you gotta do is take the negative log. And I get the pH. I don't have to subtract from 14 because nobody cares about the POH. Okay? So once you get this, you can just take the negative log. But to get the OH minus, just divide it into 1 times 10 to the minus 14. Easy, easy. Okay? I'm going to let you come back and do these. So here's pH. Here's all the things on pH. But I've already shared all this with you. So I'm going to go through it fast. Okay, we have those definitions, pH plus POH equals 14. There's just some common household stuff again with the pH scale. That sodium hydroxide's pH is around 13. Bleach is somewhere 12.5. Household ammonia that's in Windex and Clean, Mr. Clean has ammonia in it. Okay, that's around 12. Milk of magnesia, borax, that's a laundry detergent. Baking soda, egg whites, human blood is about 7.2 to 7.4. is your blood is slightly basic, okay? Coffee, okay, is down here at 5. Gastric juices, your stomach, that's your stomach acid, around pH 1. Your stomach's very acidic. So that stomach lining has to be pretty tough.
I didn't know a banana was that acidic. Didn't know it was more acidic.
Now, just remember though, this is a logarithmic scale, so it's a power of 10. So when you have something that's a 1 versus a 2, the 1 is 10 times more acidic than the 2. The 2 is 10 times more acidic than the 3. So when you're comparing a banana at 5, well, at 4.5, okay, to your stomach, it's 10 to the 3 difference. It's 1,000 times less acidic than your stomach.
Is there anything that's like 0?
Yeah, if you have 1 molar, because the log of 1 is 0. 10 to the 0 equals 1. So anything that's 1 molar, as a matter of fact, you know, I sometimes talk about my files from H. Disappearing spoon. Lewis strengths of acids. Okay, now so here's an interesting statement right here. What is this? Before 1890, scientists judged acids and bases by tasting or dunking their fingers in them. Okay,
Real nice.
not exactly the safest or most reliable method. Okay, but then they realized that acid and proton donors. Okay, this is just talking about Lewis. Okay, so look, this one. Scientists eventually got better to handle on antimony. By the 1970s, they realized that its ability to hoard electron-greedy elements around itself made it wonderful for building custom acids. The results were astounding. Okay, they produced a substance with a pH of -31. Okay, this superacid is 100,000 billion times more potent than stomach acid. Okay, it will eat through glass as ruthlessly as water through paper. You couldn't pick up a bottle of it because after it ate through the bottle, it would dissolve your hand. To answer the professor in the joke, it's stored in special Teflon-lined containers. Okay?
Oh, that's nothing better.
Yeah. So there's all kinds of super strong acids but they're not common. So the pH scale is 0 to 14, but it's not really just 0 to 14. It all depends upon the concentration. If you have 6 molar HCl, a strong acid, then the pH is going to be a negative number.
So what would it show it as on pH paper?
Just bright red. Yes.
So you said that bases were like bitter, like coffee?
Yeah, I was surprised. I was looking over that. I said, yeah, coffee's bitter. I was thinking it'd be basic, but that had it as acidic. I don't drink coffee. I don't like the flavor of coffee. It tastes bitter to me, which is why people have to put so much sugar and so much cream into it to kind of sweeten it up.
Yeah, it's not even coffee at that point.
Well, exactly.
Yeah, I drink it more.
It's just
I would much rather have Mountain Dew.
Closing the door,
Yes, yes.
dark.
Hey, gives me a glowing personality. Okay, and so it's got orange juice and caffeine in it. It's the perfect breakfast drink. And so it really does. If you ever look at Mountain Dew, it's got carbonated water, then orange juice is the next.
What kind of stuff do you have to counterbalance to change the orange from orange juice to that color?
Just a little more dilute, just, you know.
Keep going.
Okay, so I just kind of think that this was kind of interesting here. This book, if you are a closet science chemistry nerd, okay, if you really, this stuff is really kind of interesting to you, but you don't necessarily want to admit it to anyone, this summer I recommend you read the book called The Disappearing Spoon, because it's all about the backstories of how elements were discovered, the politics of the scientists discovering them, some of the unique characteristics of those compounds. For instance, another story not related to acids, but there was a major catastrophe with NASA, and that 3 workers were working on a rocket, but because oxygen caught on fire, and the oxygen doing things, there was a nitrogen atmosphere that they did a lot of stuff in. They kept everything in nitrogen. Nitrogen is much more unreactive. Well, they're supposed to, when they want to go into work on that, they're supposed to suck out all the nitrogen and just pump it full of just normal air, so they go in there. But somehow somebody didn't do that, and those 3 guys were in there. And it's unique in that they're still exhaling carbon dioxide. They were inhaling nitrogen, but they still had excess carbon dioxide. And as long as you're exhaling carbon dioxide, that's how your brain knows that you're breathing, that you're not suffocating. So they didn't have the gasping for a breath type experience. They just passed out and died. Okay? Their body thought, because of the way the nitrogen reacts in the body and does that. So there's all kinds of interesting things like that in this book. I highly recommend it. I think it's pretty interesting, just on the background of the periodic table. It goes through just about every element. You learn about Lewis and what his personal life was, and different things and different issues that he was having on all of those things. Okay, but I digress. But I think that that's interesting to answer your question. That yes, you can have some of these super acids.
Imagine choking to death, or
Without joking to this.
like you just sitting there, you think you're good, and all of a sudden, what up,
This is-
guy?
Yep.
How you doing?
That's exactly what
Like,
happened.
they're just sitting there, and it's just like a regular day.
Yeah, and then they just pass out. They must have all passed out pretty much at the same time, because none of them were able to make it back
That
out.
would have been terrifying. You see your friend just clot. Oh, it's my time.
Exactly. All right, so you can kind of look over all of that. Here is kind of the 4 equations, and this is a lot of teachers give this out. I don't think you need this. I think just looking at that, you can do all your problems. Okay? In regular chemistry, they give them this little thing, and they can use this on the test. But that just tells you exactly, if you're going from H plus to OH minus, you use this equation. If you're going from H plus to pH, you take the negative log. If you're going from pH to POH, you just subtract from 14. If you're going from POH to OH, that's where you do 10 to the negative POH. So it just kind of shows how they're all related to one another.
So are we gonna get the 1, 2, 3, 4 on the test? Or
We'll just have to see how benevolent I am next week. I think that those are simple enough, you should know them, but. All right, so we've gone through here, so let's look at, I don't want pH and molarity. I don't want to do that. I want to get to, we're going to come back to that.
I'm so tired of saying that.
Shoot, there we go. No, okay. Got. We'll run this off, but we'll see.
Golly, there were a lot of slides.
I knew nothing about it. I could not understand one word.
There's such things as super base, like there was acid.
I'm sure there are.
seriously don't know.
still need to be going?
Well, okay, I wish we could pause it, but,
Fast forward.
If you're listening to this, just skip until Mr. Hobbs appears.
that's exactly right. Here we go. This is what I should have run off for you. We'll just do it together.
Oh, lovely.
My world's slowest printer, I'm getting it. Okay. Here we go with this. Well, I gotta go with that. We're not ready for that one yet. All right. You had a nice mental break right there. So if I'm here looking at these problems, let's see you do right here. So, and I'll give you this sheet. I'll run it off and you'll have it for Monday, but you can start practicing doing these. What are the H3O plus and OH minus if a solution has a pOH of 4.75? Let's just do number one and make sure we can do number one.
Well, we're in contact, so I just said, I thought that said pOH is negative 4.75.
Yeah.
What?
All right, are we done? All right, so what did you guys choose to do? You have the pOH.
Raise it to 10 to negative.
Okay, and what's that gonna find me?
Your OH minus.
So the OH minus is gonna equal 10 to the negative 4.75. And that turns out to equal what?
1.78 times 10 to negative 50.
Okay, and that's always gonna be molar, because brackets are molarity. Okay, now, how do I go and find my H3O plus? You got two choices.
14 minus 4.75, and then do the same thing.
Okay, so pH is equal to 14 minus 4.75, which is gonna equal 9.25. So H plus is gonna equal,
5.6.
well, hold on, what do I do?
10 times raised to negative 9.25.
And that's gonna equal
5.62 times 10 to
negative 10
-10.
molar. Now, there was a different way we could have done that. Did anybody do it a different way? Well, how'd you do it, Madison? Once you found, did you go to this first?
Yeah,
Then what?
I took the 1 times 10 to negative 14 and divided it by that.
Okay, so you did H3O plus is equal to 1 times 10 to the minus 14 divided by my OH minus 1.78 times 10 to the minus 5, and you're gonna get the exact same number. Okay, 100% correct. Really, to me, about the same effort level to get there, because all these equations are related. You can just kind of, on that square we were just looking at, you might want to go clockwise to get from point A to point B. Some of y'all might want to go clockwise, counterclockwise to go from point A to point B. It doesn't matter, you're going to get to the same place. Okay? So, there's not just one way to do it. So, how's 2 going to relate to number 1?
It's just the opposite. It's the same thing. You just do it the opposite way.
You just do it with the pH, okay? So, let's look at number 3. LiOH, what is LiOH? Acid or base? How do I know it's base? OH minus, right? It's an alkali metal, it's a metal hydroxide, that's a base. Is it one of our strong bases? What family's lithium in? Alkali metals, therefore, yes, remember it makes the block, little block B, 37, 38, 55, 56, that's the B, the bottom part of the B, and then the stem is lithium, sodium, potassium. Okay, so it makes a block B for your 7 strong bases. So, what does that mean, strong base? 100% ionization. Okay, so if I put in a 0.635, if I put in LiOH into water, 100% ionization, what's it going to break up into? In this case, dissociation. Li plus and OH minus. So if I put in 6.35 times 10 to the minus 1, 2, 3, 4. I don't care about the Li concentration. What's my OH concentration going to be? For every one of these, how many of these do I get? 1 and 1, right? So if I put this much in, how much of this am I going to have? That same amount. When you're dealing with a strong acid or a strong base, however much you put in, because it's 100% ionized, that's going to be the concentration of your H plus or your OH minus. So, I know that my OH minus is equal to 6.35 times 10 to the minus 4th molar. Once I know that, I can just go through and I can figure everything else out just like we were just doing, right? So when you're putting in a strong acid or a strong base into water, ionizes 100%, whatever the concentration is, that's your H plus or your OH minus concentration, and then you just do the problems all using this. Okay? So go ahead and just finish this one and we're done for the day. you can now stop the video. Y'all have a great weekend. Go Jags.